This is my trusty Xeon E5 16ATV2. It's seen me through many endeavours. Today's endeavour shall be a lapping process in which I try to lower my temperatures when gaming or when under load. We'll get into what lapping is in a minute, but first I want to mention why I'm doing this. This Xeon is for the X79 platform and is quite easily the best of the lot. Having 8 cores and 16 threads completely unlocked means this CPU is ready for overclocking on a decent motherboard. Now, the end result of lapping a CPU looks like this generally. So what is lapping and why do enthusiasts do it? Lapping is usually done on a processor that has its CPU die connected to its integrated heatsink via solder. I therefore cannot remove the IHS and I must smooth off the IHS in order to get better cooling results. All integrated heatsinks are designed to be flat, however, factory imperfections when the CPU was built can mean the surface is not always like this. This is an example of a convex IHS on a CPU. You can see that the IHS is not all that flat. What lapping this CPU will do is to make the rounded IHS much flatter than before, effectively cutting off the rounded bit. Cooling performance will be much better after lapping a CPU generally, due to the heat being able to be transferred more evenly across the IHS surface. It can either make temperatures worse, or in fact stay exactly the same if done improperly. So then, let's go on to the testing aspect to see our temperatures before we start this procedure. A good program to get exact temperature results is Core Temp for Windows, as it gives a core by core temperature reading. We shall simply stress test the CPU for 10 minutes and record our results. As can be seen here, our highest core temperature was 82 degrees Celsius. Time to lap the CPU then. Let's just unplug everything from the PC and take it somewhere where I can work on it. Time to remove the screws from my cooler with even force, therefore taking them out diagonally from each other. Whilst I'm at it, I'm going to clean the CPU block heat spreader and we can plonk it down somewhere random in the case. Of course, now it's time to remove my processor, but I must clean this first as well. As can be seen here, my processor actually has some weird copper-like mark right in the centre. I bought it like this and it has not affected performance, but I feel like it has a higher centre than at the edges, so lapping it is very likely to drop temperatures. At the back are all the pins of my CPU. Be very careful not to touch these when lapping your CPU. Next bit is to flatten out my IHS. How to do this, you ask? That's right, lots of sandpaper. I've put together a set that varies from 400 grit right the way up to 7000 grit. We start on 400 since we want to remove a lot of the IHS, plus this is much rougher than 7000 grit. Consider anything above 1000 grit or so as what we'll use to polish and remove the very small blemishes. Now, you'll need to find a very clean and flat surface to do this on. I recommend a glass table, a mirror, or anything of a similar calibre, so long as it can be placed flat on the ground. Start with 400 grit sandpaper in a circular motion until you feel the IHS is flat. As you can see, just by a few circular motions, the CPU is starting to come away generally at the centre, confirming my thoughts that this IHS was not entirely flat. We next use 600 grit sandpaper to start polishing off the result, yet still wearing away at the IHS. Beyond 600 grit, we use 800 grit, and so on and so forth. Keep going in this fashion and make your way up to the higher grit sandpaper when you feel you have done enough on each piece. By the time I had reached 7000 grit sandpaper, my CPU looked pretty shiny. Shiny enough to see myself in. I will admit, the camera could not pick it up very well. Excuse the shaky video here where I tried to show the reflection in it. Before placing your processor back in your PC, it may be worth finding a paintbrush or a cloth of sorts to clean off any excess dust that has probably accumulated on your CPU. After having installed my processor back into its socket, I put a healthy blob of thermal paste on. I actually ran out after this, so I need to buy more soon. I now need to place my CPU block back on top with even force. This involves me screwing on each screw diagonally to each other for even placement. Time to get this back to my lair, where the testing can begin again. Now that I have turned my PC back on, I am listening closely to hear the BIOS beeps letting me know that it's started up correctly. And the CPU works fine. Phew! Let's wait for it to boot up so we can get back to testing, eh? It's now a day after the procedure since I didn't get a chance to test it in the same day, but here we're going to get the CPU under load and see if it has actually made a difference. After 10 minutes under load, I can safely say that the temperatures have been reduced, not by much, but they're definitely lower. With a maximum temperature of 78 degrees Celsius this time round, there's a 4 degree drop in temperature compared to 82 degrees maximum in the previous test. This might just be down to room temperature and time of day that caused this, but I can certainly say that the results have not got worse. All in all then, this was a good experiment to carry out and it's even made temperatures better, though not by much. The effort put into this shows that it can be a bit of a waste of time to only lower temperatures by 4 degrees, but has resulted in temperatures to be more even across the chip itself. If you feel that you want to carry this out, I'm not liable for what you do, just be careful about it as you will void your warranty. Thanks for watching, bye!